I started my video with a cough. That's not very nice of me. Okay, this video is on 4.2, which is system of linear equations, still with matrices. So really, this is more of an introduction to a matrix. So I'm going to share my screen so you can watch my notes. Maybe. All right. So again, this is 4.2. So the first thing is when I talk about a matrix, what is a matrix? It is just an array of numbers written with brackets. So a matrix, I always think of the movie. Not that I liked the movie, but I do always tend to think of the movie when I do this one. Okay, so a matrix is an array with square brackets like this, okay? And you will have numbers inside. So there's an example of a matrix. By now, you've probably seen them. If you did Algebra 2 in high school, then you've worked with them a little bit. So what we call each one in here, each number is an element. Okay? So each number is an element. The other thing is how we are going to tell the size of a matrix. So this one has 2 this way and 3 this way. So this is a 2 by 3 matrix, and that's our size. Okay, so they call this N, they call this M, and they will tell you the dimensions of a matrix that way. Let's see. I was peeking at my notes. So what would this one be? Let's just do one example here. You like my boring numbers? 1, 2, 3. What would be the size of that matrix? Right, we go this way first and then over. So it's a 3 by 1. Okay, so just to make sure we know that. Or the dimensions, sometimes that's called that. Let's see. The other thing is, how can I tell a spot in a matrix? Well, so for example, how am I going to tell you where this number is or where this number is? Well, I'm going to do an example of this. So we will say, I'm going to call this problem 2. A is our matrix A. So I'm going to call the whole thing A. And this is going to go 1, -4, 5, 7, 0, 2, 11, and -6. I stole this problem from the PowerPoint. And how would I then say this position right here? Well, we want to start with this way. So which row, why couldn't I think of that name? Versus column. Which row is this number on? It's on row 1. Which column is it in? Column 1. So we would label this A11, and that number is 1. So A11 refers to column 1, row 1. Other way though, row, column. So let's say in your notes that it goes A, make sure I do it the way they did. They did I and then a J, where I is the row and J is the column. Okay. So if I said spot 1, 2, which one am I referring to? 1 on the first one, 2. So this is -4. What if I went to 1? Which one am I referring to? Well, 2, 1. So I'm referring to 5. What if I say 4, 2? And those are subscripts. So 4, 2. So 4, 2 is -6. So you probably get the point. So a lot of your homework at the first part is like, what's the size or the dimensions of this matrix? Um, what is the element 1, 1 or element 1, 2? Okay, they might talk, let's see. Sorry, my notes are usually on paper, but I took a different car and forgot them. So I have them on the computer. All right, so what if we have a system of equations like 3x minus 4y equals 7 and 2x plus 5y equals -2. So what if we have a system of equations, which kind of follows what we've been doing? How am I going to label or write this as a matrix? So the first thing is the whole idea is we're going to just take these numbers away and we consider these first ones coefficients because they're numbers in front of letters. And then these ones we're going to call constants. So if I went to write this, I could write it as a 3, -4, 2, 5, and we could call this right here our coefficient matrix. Okay, if I did the 7, -2, we would call this the constant. Oops. But the typical way is to write them together as an augmented matrix. So augmented would be to put together those two. So you'd have 3, -4, 2, 5, and then you add the 7, -2, and you do a little line to separate off that constant or what it equals on the right side. So this is what we call an augmented matrix. So you will have to take a system of equations, it could be a 3 by 3 as well, and you're going to have to write it in this augmented form. Okay, so I think quite a few of your questions will be referred to this. Now, if I have an augmented matrix, I'm allowed to do certain things to that are called row operations. Okay, so these are called row operations. And these will be really important because we're going to use them for 2 chapters, I think, maybe even 3. So we do a lot of matrix work because you can take a lot of business situations and throw it into a matrix and make it give you your answers. So the first row operation that is allowed, I'll just star it here, is 2 rows are interchangeable. I can't spell interchangeable. Okay, and the way that we do that is we would say row, whatever the row is. I'm going to just use an I. Could be row 1, row 2, row 3. I kind of goes with those rows. Interchanged with row, and then they use a J, which is usually our columns. I guess they just use the IJ just because they like them. So what I'm saying is row 1 can switch with row 2. Or row 3 can switch with row 1. So you have to take the entire row of the matrix, but you can change them. Does not work for columns, only rows. Okay. My second rule that's allowed is you can multiply any row by a number. So you can multiply that doesn't look like any. By a non-zero. So the way that we show this is maybe we have row 1 of our matrix and we want to times it by 2. Then we show it by 2 times row 1. And so the notation kind of goes, it would be the 2 times row 1. In this case, we'll call it K, which stands for our 2, and row I. And then it's going to become the new row I. So what did I do? I times my current row by something and replaced it. Very helpful. We'll use that a lot. You can also add one row to another row. So you can add or subtract, really, any two rows. And this will become important because we are going to use this constantly. Okay, so we would say like row 1 plus row 2, I should use I and J, and replace it on either row I or row J. So you're going to add 2 rows, and then you're going to replace it, and this arrow means replace. And same thing kind of up here too. So what we're saying is, I'm going to add 2 rows, and then I have a new row, and you have to pick a spot for it to go. You don't want to put it on both because then you've changed your entire problem. So I add 2 rows, and that becomes a new row on one of the 2 spots for the 2 you added. Okay, those become important. So let's go ahead and do what we call, well, let's do a couple more things in our notes first. If I use this matrix method to solve a systems of equations, then I am going to, so I'm going to solve a system with row operations, so with matrices. Matrices. Okay, my handwriting's sloppy today. So if I'm going to do this, the goal, this becomes really important, is to make it look like 1, 0, 0, 1 with our little line M in. So our goal is to get 1s and 0s on this side, and then my solutions will be here. You could also call these X and Y. This will basically get me out X and Y instead of M and M. That's it. It really is. That's how it's going to work for you. So let's take a matrix, and we're going to get these 0s and 1s. So if I think this is my 4th kind of actual problem. If I have the problem 3x1 plus 4, I'm going to do these x2s. I'll explain it in just a second. Equals 1, and x1 minus 2x2 equals 7. So if you look at this problem right here, I could have wrote x and y. I didn't have to use x1, x2. That's just what your book specifically uses for the next couple chapters. So it's kind of a pain because when you write it in, you have to do the subscript. But do know I could call these x and y's or x1 and x2. They're different variables. So what we're going to do is we're going to first write this as an augmented matrix. That's going to go 3, 4, 1, 3, 4, 1. And then the second row goes 1, -2, 7. Okay, we know we have our little line separating our coefficient matrix from our constant matrix. Then from here, we're going to use our row operations to get the 1s and 0s. So you want to start with the 0s. Okay, and if you do it in the same order, every time it'll make it actually easier and you won't get as frustrated. So our first goal is going to be to get a 0 here. So goal 0 there. So in order to get a 0, I would like to add these 2 rows and make that 0. Well, right now, 3 and 1 do not make 0. They make 4. So what can I multiply this row by to where it will add to row 1 and make our 0? -3. So it is legal to multiply a row by -3, so we're going to do that. So we're going to say take -3 times it by row 2. Now I don't have to put I or J. I can actually use my row 2. And I'm going to replace that on row 2. So just going to times and replace that. Now, after one problem, we can do this in less steps. Obviously, I'm going to draw out all these steps for you. So we're going to take and just multiply that one by -3. So we didn't change the top one. Okay. So -3 times 1 is -3. -3 times -2 is 6. -3 times 7 is -21. Okay, so now we're here. Now what do I do? Well, now I can add them and get the 0. Okay, so the last thing you're going to take care of are the ones. You just focus on the zeros. Okay, and then we'll get the ones, and you'll see what I mean. The last step will be the ones. And I think my math lab shows you a little different. You'll end up getting frustrated. Just focus on the zeros first. So we're going to get a 0 here. So I'm going to take row 1 plus row 2 and replace it on row 2. I want the 0 here. So when I add them, I want this row to be the new row. Okay, so I'm going to keep row 1 the same, change nothing on that row, and then I'm going to add them. 3 and -3 is 0, 4 and 6 is 10, 1 and -21 is -20. Okay, now I could make this a 1 next, but well, I guess I could. It'll make the next step a little bit easier. It doesn't matter. So I have a 0 here. That's my first goal. So the next goal is a 0 here. The way I could do that is I could divide or times by 1/10, or divide everything by 10, and that would now become a 1. So I'm going to divide by 10, or take 1/10 times row 2, replace that on row 2. So I'm going to now have, I still have 3, 4, 1. I have not really changed the first row at all. 0 divided by 10 is still 0. 10 divided by 10 is 1. -20 divided by 10 is -2. So now I'm here. I have my bottom row. So let's focus on that top row. So the top row, we want a 0 here. Okay, so numbers down the diagonal. 0 here, 0 here. So what could I add together here in order to have a 0 where the 4 is? Because right now we'd add and get a 5. Well, if this was a -4, then they'd add the 0. So I'm going to take -4, and watch, I'm going to do this in one step. I'm going to take -4 and I'm going to multiply that by row 2. Okay. I'm going to take this row, multiply by -4, and then add it to this row. But watch, I can do that in one step if I want, and then add it to row 1, and I want to replace it on row 1. So I'm going to multiply, add, replace in one step. Okay, what row are we not changing? We're only changing row 1. So our outcome will only be on row 1. So row 2 is going to stay 0, 1, -2, which is what we want. So we're going to take -4. I have to scroll down so we can see this other matrix. So we're going to take -4 times row 2. So what's -4 times 0? Well, it's 0. 0 plus 3 is going to give me 3. So I'm going to go back up, put a 3 here. Okay, I'm going to go back down. -4 times 1 is -4. -4 plus 4 would give me 0. So this one now becomes 0. And you always have to do everything to this last row. This is where people will make mistakes. -4 times -2 is +8. I almost said negative. So +8 plus 1 is 9. Woo! See, we did it a little quicker, just a little. We did the multiplication, the adding. Now, how can I make this number a 1 so it goes 1, 0, 0, 1? I can divide this row by 3. Obviously, this one works out really pretty because that's the way I made it. So last step is to take and divide row 1 by 3. I don't have to write it as 1/3. You can just do it as dividing by 3 or however you want to write that. This will replace on row 1. Okay, so the only rule, so we're going to divide that by 3, 1, 0, 3, 0, 1, -2. Okay, we now have our solutions. This row was our x1 row, this was our x2 row, and we're saying one of these x1s, 1 equals 3. Okay, so x1 equals 3, x2 equals -2. I know it seems silly to use this method, but I'm telling you, you need to practice it. It will be something that you'll have to show your steps on and it will be required. It's actually a concept that comes up quite a bit that you can use in business. Okay, so I'm trying to remember if you have to do these. So the only thing, so if you follow the PowerPoint shows on the calculator and things. I don't want you to learn the calculator until the next section, and I'll happily show it to you. I just want you to practice these row operations without it. What was the only row operation we didn't use? We didn't change any 2 rows. It isn't an operation we use a lot. So mostly you're going to multiply and add to get those zeros. Let me just double check real quick. I don't think we have any 3x3s until our next section. So of course, like I said, my notes aren't. Yeah, I think we're good. One other thing I want to make sure we know is if we have a system of equations that doesn't have a solution. So in the matrix form, what happens is you end up with a row of zeros. So here's an example. We know that if we have one solution, you will have kind of what we just had. You're going to have a 1, a 0, a 0, a 1, a line, and then you're going to have some number. I almost want to call them x1, x2, but I'll follow theirs. This means you have one solution. So you have a solution xy, mn, x1, x2, whatever you want to call them. What if I have no solution? Then what I'm going to end up with, I'll just follow the process and I'm going to end up with, I don't know what here, I don't know what here, but you're going to end up with a row of zeros and a number over here. So M and P can be any numbers, don't care. So basically you get a 0, 0 number. It's the same thing as saying 0 of x1 and x2's equals some number. Well, you can't times things by 0 and get a number. It's the same as getting like 0 equals 5 or something like that. So this would be our no solution, and M, comma, N, and P are numbers. Okay, so last one is infinitely many solutions. So what will happen with this one is you're going to get whatever, a 1, an M, an N, and you're going to get a complete row of zeros. I don't care if that row of zeros is on the top, bottom, you know, you could end up with 0004 or something like that, and get no solution. It could be your top row. So whether it's the bottom, when you first do it, is different, okay? So you might end up with the zeros up here. They do like you to interchange and always have them at the end, but we aren't going to quite get to that idea yet. We're getting there. So you could have no solutions, many solutions, and this is how they'll come up when we're in our matrix form. Okay, so big ideas for this one, being able to label a matrix. I think this homework will go pretty quick, and the idea of row operations, and then more of this to come in the next section. It doesn't want to turn off.